Hello everyone, welcome to the Azure Disk Encryption and Key Management session. My name is Devendra Tiwari. I am a Principal Program Manager in the Azure Security Engineering team. We'll talk about the Azure Disk Encryption solution and its capabilities. And I have with me Sumit Berde, who is a Principal Program Manager in the Azure Key Vault team. And he's going to talk about the Azure Key Vault service, its capabilities, and how the encryption offerings in Azure use Key Vault. Now, this slide shows the Azure platform, starting with the infrastructure services at the bottom of the stack, on which the different cloud offerings like infrastructure as a service, IaaS, platform as a service, PaaS, they are deployed. Now, for the Azure Disk Encryption, we have three different components which we interact with. The first thing is the Azure IaaS virtual machines, on which you enable the Azure Disk Encryption to protect the OS and the data volumes, the disks. Then the second thing is the Azure Key Vault, where the customer secrets and the keys are securely protected and stored in a central location. The third one is the Azure Active Directory, which is used to manage the users and the apps centrally to provision the principals to access the Key Vault for their respective applications. Now, why Azure Disk Encryption is an important feature? Why most of the organizations need Azure Disk Encryption? The Azure Disk Encryption is needed to help customers meet their regulatory and security requirements and commitments to keep the data encrypted and protected at rest. At the same time, it also helps you to control the encryption keys, which are stored securely inside your Azure Key Vault service in your subscription. Now, it enhances the security of your virtual machines and the respective workload. Now, where both the Azure virtual machine owner and the Key Vault owner, they must approve any access to the IaaS virtual machines when Azure Disk Encryption is enabled. Now, it also helps protect the VHDs or the disk for thefts like offline scenarios where somebody, let's say an organization insider or a malicious advisory who has gotten hold of the the VHDs. In that case, even if the VHDs are stolen, then they cannot do much with those VHDs because the decryption of the VHDs or the mounting of the VHDs cannot happen unless they have the possession of the keys which resides in the Azure Key Vault. Now, what is Azure Disk Encryption? Azure Disk Encryption is an encryption capability or solution which helps you to protect the OS volumes and the data volumes on your IaaS or virtual machines for both Windows and Linux. It uses the industry standard encryption capabilities. For Windows, for example, it uses the BitLocker encryption capability, and for Linux, it uses the de-encrypt encryption capability. Now, the solution is integrated with Azure Key Vault service to protect the customer keys and secret into the respective Key Vault containers. And the Key Vault is residing in their subscription where customers can grant the access policies to the respective applications which are going to use the Key Vault. The customer can control the entire access policies, the inception of the keys, the birth of the keys, the secrets, and at the same time, the revocation and rotation of the keys. Now, what are the different scenarios we are going to support as part of the Azure Disk Encryption? There are three high-level scenarios this solution is going to enable. The first one is migration of encrypted VHDs from your on-premise to Azure Cloud. You are enabling the encryption on your running VMs or the existing VMs in the cloud, and enabling the encryption on the new VMs in the cloud. Now, what exactly those scenario means, we'll walk you through those scenarios in the detail when we go to the demos, and at the same time we'll help you understand what exactly that workflow looks like to light up those scenarios. Now, when the disk encryption is enabled on your IaaS virtual machines, you have to ensure that you're following the principle of least privilege. You are granting the access to the keys, the secrets, and the data disk very carefully, following the least privilege model. Thereby, you control access to the keys and secrets in your Key Vault. At the same time, you can get insight into all the key usage, the audit trail, the activities which is happening on the VMs by virtue of enabling log collection or monitoring, and then pushing those logs, or you can say events of interest, into your storage account, thereby enabling monitoring and logging of those VMs, or enhancing the security of those VMs. Now, when the data is encrypted inside your IaaS virtual machines using the Azure Disk Encryption solution, the data stays protected at rest inside your storage, and the data is still automatically replicated by the Azure storage service. Now, the solution availability will be making the preview of the solution available in coming weeks. Now, I'll hand it to Sumedh, who's going to talk about the Azure Key Vault service and give you a demo about the Key Vault and the usage of the Key Vault.
Thank you, Devendra. The Azure team has been on a roll. In the recent months, we've announced encryption in the storage client SDKs. We've announced encryption built into SQL, both the server side as well as Azure DB. And now this, with VM encryption, we have encryption built into our VM stack. And then there is a raft of third parties also doing all kinds of encryption products. Now, along with encryption comes keys. How do you protect those keys? How do you securely store them in Azure? How do you distribute them to all the right places in Azure that need them, and only to those right places? How do you prove to your compliance officers that you did the right thing with respect to your keys? For all of these questions, we created the service, the Azure Key Vault service. That's your central place to manage keys. So what is a key vault? A key vault is your personal container for your cryptographic keys and secrets. Keys is good to understand, easy to understand. Secrets is stuff that is in your application, like maybe SQL connection strings, certificates, passwords, and so on. For all of these crown jewels in your application, this is one central container to manage them all. It helps you stay compliant. You manage the lifecycle. You control the lifecycle of your keys and secrets. You add them, you remove them, you update them, you monitor access to them, you decide who should get access to it when. So that way, when it comes time to prove to your compliance officers, you have a very detailed proof that you are doing the right thing with your keys. It is backed with level 2 HSMs. We use Thales Enshield HSMs, the state of the art, with respect to hardware security modules. These hardware security modules are specialized to store cryptographic keys securely. They are like Hotel California. You can put keys in, they don't come out. So that way you are at peace that your keys are not proliferating all over. The solution we are doing helps you reduce your costly mistakes. For instance, if your keys were lying around in source code or on a SharePoint somewhere, chances are there are 1 million copies of it already before you know it. Similarly, if they are in every single workload, let's say you are managing your VM keys separately from your storage keys and from your SQL keys, one day you're going to make a mistake somewhere where you forgot to update something. This helps you centralize all of that in one place. And then furthermore, some common things that you do with your keys, like rolling keys every 6 months, getting access logs, and so on, is built right into the service. While we did this, we had our eye out on big organizations trying to come to Azure. In many big organizations, typically there is one department, one group dealing with your SQL databases and with VMs. And then there is a security officer who typically deals with things like keys. And this segregation is extremely useful. That way you make sure that your SQL databases cannot just leak, that your VMs cannot just be copied out of Azure and go somewhere else. There's two people looking over each other's shoulders to make sure the right thing happens. Key Vault is built to enable that right out of the gate. It is a multi-tenant service built into Azure. So you can very quickly, within minutes, create your own Key Vault. You can scale it up. You can scale it out across the globe. At this point, we are deployed in 15 Azure regions across the entire world. And so you can create your own container wherever your rules, your regulations, or wherever your app needs to be. And you can do all of this within minutes. And then finally, unlike provisioning specialized hardware yourself for your keys, we build this in a way that enables your developers to quickly spin this up for almost no cost, build your applications, test it, and then gradually jack up the security controls and the diligence that you put around your keys while keeping your app exactly the same. So you can move from your development and testing to your pilot to your production without really changing your application model. So a bunch of good benefits. Let's quickly take a look at how this plays out. Typically, a security officer is the one that's creating keys for you in your application. Now, during development, it could be the developer himself doing this, but in production use cases, it's a security officer. The first thing we ask in any encryption scenario is that the security officer create their own key vault. They authorize which applications and which users access this key vault, and then import or create these keys right inside the key vault. At this point, all the keys are in Azure in your key vault, and they are ACLed correctly. Now, independent of this, developers can deploy one or more applications, and these can be large teams, but they are hands-off from the keys. They deploy their applications. The application needs to be configured with the URI of the key that it needs to use or secret that it needs to use. At runtime, the application will authenticate to Azure Active Directory. This is the one choke point where your organization can control which users and which applications are in or out at any given time. Once it authenticates, the application can use your keys. Use meaning you can ask Key Vault to decrypt on your behalf or sign on your behalf, but you cannot read the key back. Those transactions, Key Vault in turn delegates down to a hardware security module, and that's the boundary within which all of the cryptography happens. So that way your keys are locked inside specialized devices. Over time, the security officer may update those keys, doesn't have to coordinate with the developer. The application just picks up the latest keys at any given point. So that way, every year, there's a new key that your data gets encrypted to. Another part of the security org may want to monitor the logs of who's accessing your keys when. So that generally is the workflow. Now, actually, one thing I forgot to tell you was, in this workflow, that application is something I showed here as custom built by the developer. This could be your SQL database in the cloud. This could be your VM in the cloud. This could be any multi-tenant service like Exchange or something that you're deploying. So we made this work in a fashion that's agnostic across which kind of application it is. So before we get back to the Azure Disk Encryption, let's do a quick demo of how you would set up your Key Vault. The interface to Azure Key Vault is PowerShell. The first thing you do is log into your Azure subscription. I've already done that to save time here. Once I have an Azure subscription, I launch into PowerShell and say new Azure Key Vault. That's the command to create a new Key Vault. I specify my Key Vault name. Let's say Devendra here belongs to the finance group, and he's creating a set of VMs belonging to the finance group. Let me create a vault called Finance VM Vault. I will specify a location it needs to be. In this case, I want it to be in the East US region of Azure. And I create it in the SKU called Premium, which enables me to use HSMs. This is a costlier SKU, but it enables me higher security. One additional parameter I need to specify is which resource group name I want to create this. This is just for grouping of your resources in Azure. I already have a resource group here called Finance Apps. I'll create it in it. Takes a few seconds. My Key Vault is ready. It's ready to receive keys. The important things in this Key Vault are this URI. This is the URI by which the Key Vault is known. The other important thing here is the access policies at the very bottom. What you'll find here is that at the beginning, I, Sumedh in this case, have some permissions to keys. I can fetch a list of keys. I can add keys, delete keys, list keys. I cannot actually encrypt or decrypt, but I can do the management operations and some permissions to secrets. The next thing I want to do is to add permissions to a particular application to be able to wrap and unwrap with it. So the command over here that I'm doing is set Azure Key Vault access policy. I specify the vault name. It was the vault that I just created. I specify an object ID, which is the ID of the application in Azure Active Directory. In this particular case, there's an application that I'm authorizing, and the permissions I'm giving to it are wrap key, unwrap key, encrypt, and decrypt. So I'm letting this application now call into this vault to encrypt and decrypt. There are other kinds of operations it can do, sign and so on. I'm saying it cannot do that. I'm saying this application cannot add or remove keys, but can just do this much. And then finally, let me add a key to this. And that's as simple as add Azure Key Vault key minus vault name, again, finance VM vault, that's the vault name, minus name, I'll give a name to the key, and I'll call it finance VM KEK for key encryption key, and you'll learn why I'm calling this soon when Devendra does his demo. I will ask Key Vault service to back this up with HSMs. So I'll say destination HSM. So at this point, I have a key. The gobbledygook that you see over there is the public key value of this particular key. What's important at this point is this ID of the key. This is the full URI of the key. This is what I will pass to Devendra as the place that he will use to encrypt all his VM keys. Over time, 6 months later, I may want to update the key, and all I do is I run the same command again, and it adds a key to my Key Vault collection with the same URI, and that URI now becomes a collection of keys. So that quickly is the summary of Key Vault service. With that, let me hand it back to Devendra to do the rest of the Azure Disk Encryption demo.
Thank you, Sumit, for showing how the Key Vault container can be created in a subscription, and then how the keys, particularly the key encryption key, can be created, and then how the access policies can be set so that applications like Azure Disk Encryption can leverage the Key Vault to store the keys and the secrets securely. Now, what we are going to see in the demo for the Azure Disk Encryption is we have created a few ARM, the Azure Resource Manager templates to show you how the different scenarios we called out earlier as part of the Azure Disk Encryption support. The scenario for bringing in encrypted VHDs from on-prem to cloud, the scenario to enable encryption on a running VM or an existing VM in cloud, or the scenario to enable Azure Disk Encryption on a new VM in cloud. Now, what you see here on the screen is the ARM templates which we have uploaded on the GitHub site. Now, scenario 1 shows the template which creates and deploys an encrypted Windows VM on Azure, where the BitLocker encryption key is encrypted by a key encryption key. So the key encryption key, which Sumit was showing earlier, is used to protect the BitLocker encryption key. Now, I mentioned earlier that for the Azure Disk Encryption solution on Windows, it uses the industry standard BitLocker encryption solution. Now, when you bring your encrypted VHD or pre-encrypted VHD from on-prem, you have enabled encryption on, let's say, VM, you get the encrypted VHDs, you get the BitLocker encryption keys, and then you have the key encryption key to further protect the BitLocker encryption key or wrap the BitLocker encryption key. Now, what you need to do is you need to upload the encrypted VHD into your storage in Azure. You need to upload your BitLocker encryption key wrapped by the key encryption key into your Key Vault container, as Sumit was showing earlier how the Key Vault container can be created. And then once you have done that, you come to Azure, and then you use this ARM template, and then you click on the deploy to Azure button here. Now, when you do that, it opens up ARM template as you see it in the portal UI. Now, for the purpose of these demos, it expects a virtual machine name, the VM name, which you want to provision from that encrypted VHD, from that encrypted payload. And then it includes the URI where your encrypted VHD is uploaded. Now, once you have done that, inside the template, we have referenced the Key Vault URI, which Sumit had earlier created and handed it to me. So we are using that, and with just by entering the VM name and reference to the OS encrypted VHD, and then of course calling out that this is a Windows VM or the Linux VM. So in this case, we are demoing the Windows VM. You say OK, and then you basically select the resource group. So for the purpose of this demo, I am picking up the resource group which was already created, and then you opt into the legal terms of using the or consuming the ARM template. Now with that, you have now inputted all the information which is required to request a new VM or a VM from Azure for your encrypted scenario. Now I would click create, and that would spin up the pre-encrypted, that would spin up a new VM from the pre-encrypted or from the encrypted payload. Now while that is happening in the background, let me also show you the demo for the Linux VM. Now for the Linux VM, the flow is kind of more or less similar, where on your on-prem you have a Linux virtual machine. You create a VSD out of the Linux virtual machine. For Linux virtual machine, we use the dmcrypt as the encryption technology, and in case of dmcrypt, it requires you to input a passphrase to securely protect the VM. So we have here the ARM template for the Linux scenario as well, where you can spin up or you can request Azure to spin up a Linux VM from your encrypted payload or the Linux encrypted VSD. So when I click on the deploy to Azure, it's going to open up this UI template or the ARM template in the portal UI. And these are some of the parameters which you need to input, similar to what we were what we have seen earlier. For the Windows VM, you have to input the VM name. You have to input the location of your encrypted VSD, which is basically your Azure storage location where the VSD is uploaded by you. Now once you have done that, then, and of course you have to enter the OS type, in this case which is Linux. So you click OK. Again you select the resource group you want your VM to be provisioned under. Then you basically accept the legal terms, again similar to what we have done for the Windows VM. And then once you have done that, you hit create, and then Azure will provision a Linux VM for you from your encrypted VSD. So while that is happening, let's take a look at how our previous deployment is proceeding. So its deployment has succeeded. So we are able to spin up a Windows encrypted VM from your pre-encrypted or from your encrypted VSD you have uploaded from on your on-prem. So moving back to the Linux demo again. So I click on buy and then I say create. So that will Azure will now spin up a Linux encrypted VM. Now let's take a look at, I'm refreshing the view of my virtual machine. So the Windows VM which we created is the AzureCon demo Windows encrypted VM 5. That's the VM we have created from our encrypted payload. Now when we go back to, let's see how our Linux VM deployment is proceeding. So it has started and it's on its way to completion. So this basically shows you that from a encrypted VSD coming from your on-prem, you can request Azure to provision a new VM which is protected at rest from your encrypted payload. And the keys, they are residing inside your key vault. They are under your control. You then grant access to different applications. Now one thing to note here in this case, since the Azure Disk Encryption solution needs access to your key vault, while you are setting up your key vault, as Sumedh was showing earlier, you have to set enable for volume encryption property on that key vault container, so that the Azure Disk Encryption solution or the feature can access your key vault and then help you provision the IaaS VM for both Windows and Linux at runtime. Now, so the deployment is almost about to complete. Now let's refresh and see if the Linux VM is provisioned. So it's still going on. So let's move on to another demo. Now we talked about 3 scenarios. So we demoed you the encrypted VSD scenario for both Windows and Linux. Now I want to demo you the running VM scenario or a IaaS existing VM scenario, where you want to turn on encryption for your OS disk and the data disk on the running VM. So here I'm showing you the demo for the running Windows VM. So this is basically the ARM template for the running Windows VM, template number 5. Now when I click on that template, it opens up this template in the UI, ARM template in the UI. Now what I'm inputting here is the VM name. Now you must be wondering what are these different additional parameters which are required to be inputted by the user. Now the running VM is a scenario where what we do is when the request comes in, and I'll show you on the next slide looking into the flow, that when the request comes in, the control flows all the way from the ARM template or the PowerShell commandlets through the service management layer to the host, which is a core component of the platform, and then the security extension, a BitLocker extension or a Linux security extension, gets injected as an agent on your running VM, and that's basically initiates or triggers the encryption process. Now when the encryption process is initiated, whatever BitLocker keys which are generated as part of the encryption initiation process, those keys needs to be uploaded into your Key Vault. And as Sumedh was showing you earlier, the Key Vault authentication is all based on Azure Active Directory. So what we are requesting here from you is to input the Azure Active Directory client ID, which is for the purpose of this demo I have included here, and then the Azure client secret. So with this, the agent which has initiated the encryption operation on the VM will take the BitLocker encryption keys or the Linux passphrases for the Linux scenario and upload that into your Azure Key Vault in your subscription. So that's where this identity is required. Now there are a bunch of other things. You have to input the Key Vault URL. This shows where the agent is going to write or upload your Key Vault. So the identity is required to authenticate and to Key Vault using the AD token, and the URL is required to get to that specific container to upload your encryption key. So with that, I've hit OK, and I'm selecting the resource group, and I'm selecting the legal terms again, opting into the legal terms. So while this template is loading up, now let's see where are our what's our VM state. So as you can see here, we have the Linux encrypted VM which is created. So this is the AzureCon demo Linux encrypted VM 5 that is created from your encrypted Linux VSD, and then we have the AzureCon demo Windows encrypted VM5, which is created from your Windows encrypted payload. Now let's go back to our demo for the running VM scenario. So I click on buy here, and then I click create. Now this will trigger the encryption of the running VM scenario, which means the OS disk, the boot volume, and the data volume will be encrypted. So what we have seen in the demo is 3 scenarios. Encrypted VHD scenario for Windows, encrypted VHD scenario for Linux to provision a new VM, and for a running VM, we have seen how we can enable encryption for the OS volume and the data volume. Now, while the VMs are running, let me show you. I have here a connection open to the Linux encrypted VM. So where I am running this command. So I'm using the putty tool to connect to the Linux VM, encrypted VM, and here you can see that the Linux encrypted VM is encrypted, SDA5_script, showing that the Linux encrypted VM is provisioned in an encrypted state. Now we can do the same thing for the Windows VM. So when I click on the Windows VM here, I can RDP into that VM. Okay, so now what's happening here is I'm RDPing into the VM, showing you that the VM is encrypted. That's basically the Windows VM. So here is the the OS drive or the OS disk, which is here. You will see that the lock appears on the OS disk, showing that the OS disk is encrypted for the Windows VM. So that's basically completes the demo for the Windows VM and the encrypted VM from the pre-encrypted scenario. The running VM is still being encrypted. It takes some time to encrypt the running VM. The agent has to perform certain steps, prep the VM to initiate the BitLocker operation, generate the keys, upload the keys and all that stuff into your key vault, and then kick off the encryption thing. So while that is happening, let me go back to the slide and show you the encryption flow. Now, in this case, what is happening is what you have seen here is you have the encrypted VSD on your on-prem. Now, you created that encrypted VSD, you come to Azure, you upload that encrypted VSD into your Azure storage. You upload the BitLocker encryption keys or the Linux passphrases into your key vault, the key vault which Sumedh was showing earlier how to create it. And then once you have done that, you come to Azure. In this case, we have shown you through the ARM template how you can point Azure to your encrypted VSD. You input the VM name, the control or the instruction flows from the ARM template or the PowerShell commandlet through the service management layer into the host. Now, what host is going to do is the host component of the platform is going to read your encrypted VSD from storage. It's going to read your BitLocker encryption key or the Linux passphrase from your key vault. And that was the property I was calling out earlier, that property enable for disk encryption or enable for volume encryption needs to be set on your key vault so that the platform can perform provisioning of that VM step. Now, once that is done, then the host provisions you a virtual machine which is protected at rest, including the content protected at rest inside your storage, and the keys they are protected inside your key vault. So that is a high level flow for your encrypted VSD scenario for Windows and Linux. Now let's walk through the flow for the running VM scenario. For the running VM scenario, what we are seeing here is you are seeing that the user is coming to Azure and the user has opted into turn on encryption for the running VM. Now here there are few differences which I was calling out earlier. The first thing is that you specify the encryption configuration, which includes the Azure Active Directory client ID and the secret which the agent is going to use to talk to Key Vault to upload the keys securely in your Key Vault. And then you have to provide the Key Vault URI so that, or the reference, so that the agent can upload the keys into that Key Vault. So once the extension is pushed onto the VM, the encryption process has started now. The agent has started the encryption process. The agent is going to talk to the Azure Active Directory with the identities you have provided. The agent is going to initiate the BitLocker encryption operation, get the BitLocker encryption keys and push that into your Key Vault. And the agent is then, the encryption operation is then completed. So that flow basically shows you how you can enable, the encryption, BitLocker encryption or Linux decrypt encryption on your running VM for the OS volume and for the data volume. Now, coming back to our demo again, let's see how we are doing on the VM, the running VM on which we have enabled encryption. So let me refresh the view of that VM and let me go here and see the deployment is still going on. So what I'm going to do here is I'm going to look into a VM on which I have previously enabled encryption. So this is basically my running VM, and through the this is my running Windows VM, and through the BitLocker extension or the agent which got injected through the flow through the ARM template, the encryption is enabled and the keys are pushed into the Key Vault. So this is the OS volume on which the boot volume on which the encryption is enabled, and this is the data volume on which the encryption is enabled. So these are the three scenarios which basically shows how you can enable this Azure Disk Encryption on the pre-encrypted VMs or VSDs, or for the running VSDs, running IaaS VMs, and for the new VM. Now, a few things, trying to repeat the information which Sumedh had already provided. The secrets like BitLocker encryption keys or the Linux passphrase, they are stored, protected in your controlled key vault securely, where you control the access policies, the revocation, rotation, all that. The secrets are encrypted. I mean, the BitLocker secret can be further encrypted by the key encryption key, where you specify your key encryption key, and then you as a customer explicitly grant read-write access to your key vault container to the Azure platform to enable the disk encryption across all your scenarios. Azure do not have any default access to your key vault for the disk encryption feature. You have to explicitly turn it on. So with that, we wanted to show you that how we can use the disk encryption feature and how it integrates with Azure Key Vault service, where the keys are protected inside your Key Vault container inside your subscription. So this is the end of the Azure Disk Encryption session, where we have showed you how you can turn on encryption on your IaaS VM for the different scenarios we showed you, and how you can integrate with your Key Vault container to store your keys secrets securely, and thereby control the access policies, revocation, rotation, and all that. So with that, this is the end of the session. Thank you very much for watching the recording.
Thank you. Encrypt, encrypt, encrypt.